Hello. In this video, I'll show you how to enable AWS Config in AWS Security Hub and explore the features and details of each service. In this demonstration, I will use an account with administrative privileges in my AWS account. I'm in the AWS Management Console. To the right of the Services menu, I'll search for Security Hub and choose it to go to the Security Hub homepage. The first time that I access the service, the page gives me a look at how Security Hub works, the benefits and features that the service can provide, and some use case examples. The page also has pricing information and links to documentation, FAQs, and so on. AWS provides a 30-day free trial of Security Hub, which I'll use for this demonstration. I'll choose Go to Security Hub to get started. Before I can enable the Security Hub standards and controls, I need to enable resource recording in AWS Config. I can go to the AWS Config console through the Services menu, or by choosing the link in the Enable AWS Config section on this page. I'm going to choose this link. The AWS Config homepage opens in a new tab. Before I move any further, let's look at the information provided here. Like the Security Hub homepage, this page gives me a high-level view of how AWS Config works, benefits and features, use cases, and links to pricing information. The page also has links to documentation, FAQs, and more. For this demonstration, I'll choose the one-click setup option. This option will launch AWS Config using a setup based on the AWS best practices. You can also configure AWS Config manually if you so choose. Let's take a moment to review what the one-click option will create for me. In the General Settings section, I see the AWS Config will record all resources except global resources, meaning it will record all resources supported in this AWS region. It will also create a new service-linked role called AWS Service Role for Config. AWS Config will use this role to call other AWS services on my behalf. Now, let's look at the Delivery Method section. This is where AWS Config will send my configuration snapshots and configuration history files. AWS Config will create a new Amazon Simple Storage Service, or Amazon S3, bucket specifically for this purpose. Finally, let's look at the AWS Config Rules section. With the one-click setup option, I can't select any rules. If I needed to customize rules, I could use the manual configuration setup method, or select them in the AWS Config console after initial setup. I'll choose Confirm to get started with AWS Config. This is the AWS Config console. Let's take a quick tour and look at the information provided throughout. I'm currently in the dashboard. Here, I can see my resource inventory, compliance status, and non-compliant rules by non-compliant resource count. As I mentioned before, I can add rules after the initial setup. I'll go to the Rules page. When I choose Add Rule, a three-step rule creation process begins. In the first step, I can specify the rule type. I can choose to add an AWS managed rule, or I can create a custom AWS Lambda rule. I'll choose Create Custom Lambda Rule and choose Next. In the Details section, I can give my custom rule a name and a description, and specify the ARN for my Lambda function. The Lambda function will evaluate my AWS resources for compliance with my rule. Next, I can set a trigger type. The trigger is what causes AWS Config to evaluate resources. The trigger can be set to evaluate resources when configuration changes, periodically, or both. If I choose when configuration changes, I can then decide whether to evaluate all changes, evaluate changes based on resource type, or evaluate changes based on tags. If I choose periodic, I can set a frequency to trigger this rule, ranging from every hour to every 24 hours. Finally, in the Parameters section, I can define attributes for which resources I want to evaluate. I don't need any rules right now, so I'll return to the AWS Config dashboard. Let's take a quick look at the Resources page. Here, I can view both my existing and deleted resources that AWS Config has recorded. Note that I need to select Include Deleted Resources to see any of my deleted resources. You can see that I have an Amazon Elastic Compute Cloud, or Amazon EC2, VPC, and all of its components, including route tables, subnets, and instances. Next, let's look at the Aggregators page. An aggregator collects AWS config data from multiple accounts and regions. Because I'm only operating in a single account and region, I'll keep moving and go to the Advanced Queries page. Here, I can run custom queries against my AWS resources. I'm able to choose from a number of sample queries that AWS created, or I can write my own query using a subset of structured query language, or SQL. Let's move on and look at the final section, Settings. If I no longer want or need AWS config to record my configurations, the Settings section is where I need to go. This is where I can view the settings I created during my initial setup. The General Settings area displays the resource types to record and the AWS config role that was created. The Delivery Method section shows the name of the S3 bucket that was created for AWS config. Now that I've reviewed the details of AWS config, let's go back and explore Security Hub. I've completed the first step, which is to enable AWS config. In the Security Standards section, I can choose from 3 security standards options to enable. 2 of these options, AWS Foundational Security's Best Practices and CIS AWS Foundation's Benchmark, are selected by default. The third option, PCI DSS, isn't selected by default. This security standard is only necessary if I'm dealing with payment card processing, which requires me to adhere to the Payment Card Industry Data Security Standard, or PCI DSS. Finally, in the AWS Integrations section, I see the message that, by enabling Security Hub, I am granting it permissions to import its findings from other AWS services that I've enabled. Let's enable Security Hub and take a tour. Now that I've enabled Security Hub, the summary page displays. The information bar at the top of the page states that it can take up to 2 hours to see the results from the security checks. While I wait for those checks to complete and the data to be ingested, let's take a tour of the other sections of the Security Hub console. I'll begin on the Security Standards page. On this page, Security Hub gives me a security score for each of the security standards I enabled during setup. My Security Best Practices score is decent, but my CIS AWS Foundation's benchmark score could certainly be improved. Note that I have the option to enable the PCI DSS security standard within this page if I decide I need it after the initial setup. Let's take a look at the Foundation's benchmark to see why my score is so low. On the Foundation's benchmark page, I can see that I failed the majority of checks that were performed. Fortunately, Security Hub gives me the list of checks that were performed and the status for each. I'll look at one of those failed checks to get more details on how I can remediate. Because I haven't enabled multi-factor authentication within my demo account, the first failed check I see is Ensure MFA is enabled for the root account. When I choose the title of the check, I'm presented with more detail. The control status shows a compliance status of failed and a severity of critical. Fortunately for me, the page also gives me a link for remediation instructions, which takes me to the AWS documentation to help me fix this critical issue. I also have the option to download the finding JSON file, which provides information about the finding and a link to remediation documentation. Let's move on to the Insights page. On this page, I'm presented with 33 pre-configured filters that show related findings. I can also create my own insights if I want. For now, I'll select the first insight, AWS resources with the most findings, and view the information provided. To take a closer look at the resource ID with the most findings, I'll click the resource ID. In this case, the resource with the most issues is my AWS account itself. I'm now presented with a list of findings that displays all of the failed checks and details about each check. In the title column, I can choose the provided link to display more information about the check itself. Within the panel that opens, among the details I can view is the standard used in the check, compliance status, severity label, and AWS account ID. It also provides details for the resource itself, including the resource type, ID, and region in which it resides. More importantly, I am again provided with a link to documentation to help me remediate this issue. Let's move along and look at the findings page. This page is a full list of security issues or failed security checks. Like the Insights page, I can filter it in a number of ways, though it isn't grouped for presentation in the same manner as Insights. Now, let's look at the Integration page. This area of the Security Hub console is where you can select whether or not to accept findings from other AWS or third-party services. Security Hub provides a considerable list of services to integrate with, along with links to the service pages. If Security Hub is already accepting findings from a particular service, I would see a See Findings link. Choosing that link would return me to the Findings page, filtered to display findings only for that specific service. Let's continue on and look at the settings page. Here, administrators can add member accounts to provide access to Security Hub. You can add accounts individually or by uploading a .csv file. To download the Security Hub CSV template, choose the Upload List tab and choose the Format Details link under Account List. In the pop-up window, I can choose the Security Hub Template CSV link to download the template for future use. Returning to the settings page, when I choose the Regions tab, I can view aggregated findings if I'm operating across multiple regions. On the Custom Actions tab, I can create a custom action to configure Security Hub to send selected insights and findings to Amazon CloudWatch Events or Amazon EventBridge. On the Usage tab, I can review my overall Security Hub usage during my trial period and the amount of trial time remaining. I'm presented with a total estimated monthly cost, which can help me assess whether Security Hub is a cost-effective service for my organization to maintain past the trial period. Finally, on the General tab, I can set Auto-Enable for new controls, view my service permissions and resource policies in JSON format, and disable Security Hub if I no longer want to use it. Note that if you disable Security Hub, you will lose access to your existing findings and Security Hub configurations. This data cannot be recovered. If you would like to maintain your existing findings, export them prior to disabling the service. In summary, you have seen how to enable AWS config for use with Security Hub and explored the functions and features of the service. You have also seen how to enable Security Hub, explored the security standards it relies on, and viewed the myriad of information that the service provides. Thank you for watching this demonstration.
This section covers how to identify an incident. Incident response is a set of information security policies and procedures you can use to identify, contain, and eliminate cyber attacks. The goal of incident response is to enable an organization to quickly detect and halt attacks, which helps to minimize damage and prevent future attacks of the same type. How would an enterprise know if abuse was taking place? How would they differentiate between abnormal events that need their attention and incidents that need immediate analysis and remediation? Not all events are incidents in need of immediate remedy. Let's take a look at a few examples of such events. First, someone is logging in from a remote location. In this scenario, an employee might be traveling or using an approved virtual private network or VPN. Second, a failing hard drive that is still fully operational. If the drive is still operational, the enterprise can timely schedule a cycling of the drives without panicking or hot swapping when it's too late and has already failed. Hot swapping is the act of removing components from or plugging them into a computer system while the power remains switched on. Third, an employee trying to access resources that they shouldn't access. Although this might not constitute a breach if the access was denied, it's still a behavioral insight that you should monitor. Incident response has two phases. The first phase is discovery and recognition. Here is where incident identification, logging, and categorization of the incident takes place. Once an incident is identified through user reports, solution analysis, or manual identification, the incident is logged, and an investigation and categorization can begin. During this phase, a notification is received. Notifications are set up by the user and initiated by specified alerts to send an email, SMS text, or push notification through a mobile app. Incident escalation is what happens when an employee can't resolve an incident themselves and needs to hand off the task to a more experienced or specialized employee. Investigation and diagnosis include conducting an incident investigation to gather answers and develop strategies to resolve any threats. Keep in mind that AWS offers a range of services and products that help companies discover and identify events that could lead to or have already become an incident. When an enterprise has identified the failure of a component, a reduction in quality of service, or an exploit in need of remedy, they move into the resolution and recovery phase of incident response. Let's review what takes place in phase 2. First is forensic isolation. This is when you isolate the incident and perform a deep dive to discover the issue. Forensics often requires capturing the disk image or as-is configuration of an operating system. The problem might be a bug in the code base. If so, you need to reproduce the error. Without being able to reproduce the error that the customer experienced, you won't be able to fix it. Second, You stage a fix, which is when you reproduce the issue, apply a fix, and test. Next, you deploy the fix, which means pushing any new infrastructure as code or any new application code to production. And finally, incident closure means resolving the incident. AWS offers a range of services and products that help companies remediate an incident. Here are the key takeaways for this section of the module. Incident response is a set of information security policies and procedures that you can use to identify, contain, and eliminate cyber attacks. Not all events are incidents in need of immediate remedy. The first phase of an incident is the discovery and recognition phase. And the second phase of an incident is the resolution and recovery phase. Thanks for watching. This section highlights a few AWS services that support the discovery and recognition phase. Note that these are not all of the AWS services available. AWS offers several services that support incident discovery and recognition. These services help an enterprise identify an attack. Let's look at these services in more detail and how they support the discovery and recognition phase. Trusted Advisor draws upon best practices learned from serving hundreds of thousands of AWS customers. The service inspects your AWS environment and then makes recommendations when opportunities exist to improve performance and help close security gaps. If you have an AWS Basic Support or Developer Support plan, you can use the AWS Management Console to access core security checks and all checks for service quotas. If you have a business enterprise, on-ramp, or enterprise support plan, you can use the console, AWS Support API, and AWS Command Line Interface, or AWS CLI, to access all checks. This includes checks for cost optimization, security, fault tolerance, performance, and service quotas. You can also use Amazon EventBridge to monitor the status of Trusted Advisor checks. CloudWatch provides a reliable, scalable, and flexible monitoring solution that you can start using within minutes. By using this service, you don't need to set up, manage, and scale your own monitoring systems and infrastructure. The CloudWatch console homepage automatically displays metrics about every AWS service you use. You can additionally create custom dashboards to display metrics about your custom applications and display custom collections of metrics that you choose. You can create alarms that watch metrics and send notifications, or automatically make changes to the resources you are monitoring when a threshold is breached. With CloudWatch, you gain system-wide visibility into resource utilization, application performance, and operational health. Amazon Inspector is a vulnerability management service that continuously scans your AWS workloads for software vulnerabilities and unintended network exposure. Amazon Inspector automatically discovers and scans Amazon Elastic Compute Cloud, or Amazon EC2 instances, and container images that reside in Amazon Elastic Container Registry, or Amazon ECR. When Amazon Inspector discovers a software vulnerability or network issue, the service creates a finding. A finding describes the vulnerability, identifies the affected resource, rates the severity of the vulnerability, and provides remediation guidance. GuardDuty is a continuous security monitoring service. It can help to identify unexpected and potentially unauthorized or malicious activity in your AWS environment. GuardDuty uses threat intelligence feeds, such as lists of malicious IP addresses and domains, and machine learning to identify potentially harmful activities within your AWS environment. This can include issues such as escalations of privileges, use of exposed credentials, or communication with malicious IP addresses or domains. For example, GuardDuty can detect compromised EC2 instances, serving malware, or mining Bitcoin. The service also monitors AWS account access behavior for signs of compromise, such as unauthorized infrastructure deployments. For example, instances being deployed in a region that has never been used. The service also monitors for unusual API calls, such as a password policy change to reduce password strength. Shield helps protect an enterprise network against a distributed denial of service or DDoS attack. A DDoS attack is a malicious attempt to disrupt the normal traffic of a targeted server, service, or network by overwhelming the target or its surrounding infrastructure with a flood of internet traffic. A DDoS attack is like an unexpected traffic jam clogging up the highway, preventing regular traffic from arriving at its destination. When you build your application on AWS, you receive automatic protection against common DDoS attacks. Additionally, you can use the AWS Shield Advanced Managed Threat Protection service to improve your security posture with additional DDoS detection, mitigation, and response capabilities. AWS Config is a continuous monitoring and assessment service that provides you with an inventory of your AWS resources and records changes to the configuration of those resources. You can view current and historic configurations of a resource and use this information to troubleshoot outages and conduct security attack analysis. You can also view the configuration at any point in time and use that information to reconfigure your resources and bring them into a steady state during an outage situation. AWS Config sends notifications when changes occur and integrates with other AWS services to remediate issues. Let's take a closer look at how AWS Config works. As configuration changes occur in your AWS resources, the service records and normalizes the changes into a consistent format. AWS Config automatically evaluates the recorded changes against the rules that you've set. You can then access the change history and compliance results by using the console or API. You can configure Systems Manager or Amazon SNS to be invoked and remediate or alert you when changes happen. You can also deliver the change history and snapshot files of the monitored resources to an S3 bucket for analysis. Here are the key takeaways from this section of the module. AWS offers several services that support the discovery and recognition phase. Trusted Advisor inspects your AWS environment and then makes recommendations when opportunities exist to save money, improve system availability and performance, or help close security gaps. CloudWatch provides a reliable, scalable, and flexible monitoring solution. AWS Config is a continuous monitoring and assessment service that provides you with an inventory of your AWS resources and records changes to the configuration of those resources. Amazon Inspector is a vulnerability management service that continuously scans your AWS workloads for vulnerabilities. Shield offers protection against DDoS attacks. And GuardDuty is a continuous security monitoring service that can help to identify unexpected and potentially unauthorized or malicious activity in your AWS environment. Thanks for watching. A few services that support the resolution and recovery phase. Note that these are not all the AWS services available. AWS offers several services that help with resolution and recovery. A few services offer event-driven responses, meaning that they can respond to actions generated by the user or the system. Let's look at these services in more detail and how they support the discovery and recognition phase. Systems Manager gives you visibility and control of your infrastructure on AWS. The service provides a unified user interface so you can view operational data from multiple AWS services and automate operational tasks across your AWS resources. CloudFormation is a service that helps you model and set up your AWS resources so that you can spend less time managing those resources and more time focusing on your applications that run in AWS. You create a template that describes all the AWS resources that you want, and CloudFormation takes care of provisioning and configuring those resources for you. An enterprise can use CloudFormation to recreate a staging environment inside an isolated or forensic virtual private cloud or VPC. Once the system is isolated, the team can deep dive and discover the issue, possibly reproduce the issue, apply a fix, and test. The team can push any new infrastructure as code or any new application code to production. Amazon SNS. This is an event-driven web service that provides the ability for applications, end users, and devices to instantly send and receive notifications from the cloud. An enterprise could use Amazon SNS to receive notifications of potential exploits. AWS Step Functions. Step Functions is a low-code visual workflow service that developers use to build distributed applications, automate IT and business processes, and build data and machine learning pipelines using other AWS services. Event-driven workflows manage failures, retries, parallelization, service integrations, and observability. When your enterprise experiences abnormality, implementing step functions can help you to create complex business logic in event-driven workflows that connect services, systems, or people within minutes. AWS Lambda. Lambda is a serverless, event-driven compute service that provides the ability to run code on demand without provisioning or managing servers. With Lambda, you can run code for virtually any type of application or back-end service, all with no administration. Lambda takes care of everything required to run and scale your code with high availability. You can set up your code to be automatically invoked from other AWS services or call it directly from any web or mobile app. Lambda functions are stateless. This means that Lambda can rapidly launch as many copies of the function as needed to scale to the rate of incoming events. After you upload your code to Lambda, you can associate your function with specific AWS resources. When the resource changes, Lambda runs your function and manages the compute resources as needed to keep up with incoming requests. With an event-driven response system, a detective mechanism invokes a responsive mechanism to automatically remediate the event. Let's look at an example of using Lambda in an event-driven architecture to respond to an incident. Assume that you have an AWS account with AWS CloudTrail enabled. If CloudTrail is ever disabled, the response procedure is to enable the service again and investigate the user who disabled the CloudTrail logging. You can use EventBridge to monitor for the specific CloudTrail stop logging event and invoke a Lambda function off of it. The function collects the details of the specific event, such as the identity of the principal that disabled CloudTrail, when it was disabled, and the specific resource that was affected. This processed information could then be sent as a notification through Amazon SNS. You can use this information to essentially perform a log dive and then generate a notification or alert with only the specific values that a response analyst would require. Another Lambda function could also be invoked to automatically restart the logging. Here's an example of how to use services together to remediate a compromised instance. First, a script or third-party tool pushes an instance ID to an SNS topic. Then, a Lambda function verifies the ID and, if compromised, initiates a step functions workflow. In the first step, the instance is removed from its auto-scaling group and a snapshot is created of any attached Amazon Elastic Block Store or Amazon EBS volumes. Next, the instance is isolated by removing all its previously associated security groups. Then, a new forensic security group is assigned to the instance with no inbound or outbound permissions. Third, a CloudFormation template is used to create a new environment, including a new VPC that contains a forensic instance with pre-built tools attached to a copy of any volumes from the snapshots. Then, a basic forensics investigation is performed on the attached volumes. Finally, a report is generated with the results from the investigation and sent to the team through an SNS topic. Here are the key takeaways for this section of the module. AWS offers several services that support the resolution and recovery phase. Systems Manager gives you visibility and control of your infrastructure on AWS. With CloudFormation, you can create and provision AWS infrastructure deployments predictably and repeatedly. Lambda is an event-driven response service that provides the ability to run code without provisioning or managing servers. Amazon SNS is an event-driven response web service that coordinates and manages delivering or sending messages to subscribing endpoints or clients. And Step Functions is an event-driven response service that makes it easy to coordinate the components of distributed applications as a series of steps in a visual workflow. Thanks for watching. This section covers best practices in responding to and managing an incident. Let's look at some industry best practices for handling incidents.